Let's take a look at a second example of a Riemann sum. Okay, in this case, we have the sum as k goes from 1 to n of f of x sub k star times delta x sub k, where here f of x is x squared minus 1, a0, the left end, excuse me, which is x0, the left end point is at negative 1, x1 is 0.25, 1/4, x2 is 1, x3 is the right end is 2, and the x sub k star is the first, x sub 1 star is 0, x sub 2 star is 1/2, and x sub 3 star is 5/4. So let's take a look at what we have here. So we start off, all right, and let me turn down just the size of this just a little bit so that we can fit more stuff on the screen here. All right, so let's see. We start out at the left end is at negative 1. So here we'll have the left end is at negative 1. And then that goes from negative 1 to positive 1/4. Well, positive 1/4 will be right here. And so how wide is this interval? Well, it's going to be 1/4 minus a negative 1. And that would be 5/4. Okay, all right, x sub 2 star, I'm sorry, x sub 2 is at 1. It's right here. So how big is that? Well, it goes from 1/4 to 1, so 1 minus 1/4 is 3/4. So x sub 2 star is 3/4, and then x sub 3 is at 2. So delta x sub 3 goes from 2 to 3, or 1 to 2, so it's delta x sub 3 is 2 minus 1, which would be 1. And so let's see, which is the biggest? Well, the maximum of the delta x sub k in this case will be 5/4. You don't see while we're talking about that maximum delta x sub k, but you'll see it later on in what's happening. So we have this, all right, and so now what I want to do is I want to calculate the sum. So I'm going to evaluate this, all right. I have f of 0, all right, x sub 1 star is 0, and times delta x sub 1, which we saw was 5/4. Remember, we went from negative 1, all right, to 1/4. And if I evaluate this at 0, I get negative 1. So I'm going to have a rectangle that hangs down below the x-axis 1 unit. All right, hangs down below the x-axis 1 unit and is 5/4 of a unit wide. So this will be negative 1 times 5/4. Notice that this is going to give me a negative number. That's because that rectangle is below the x-axis. All right, then on the next interval from 1/4 to 1, all right, we have x sub 1 star is 0.25. X sub 1 star is 0.25, and oops, I'm sorry, it's 0.5. So x sub 1 star is 0.5. That's right here. Okay, so when I go down 0.5, let's see, I'll have a second rectangle. This rectangle, well, let's see, f of 0.5, f of 1/2 is going to be 1/2 squared. 1/2 squared is 1/4 minus 1 is negative 3/4. Times we're 3/4 wide. Okay, so we have that. And then f of 5, f of x sub 3 star, it's f of 5/4. Okay, f of 5 force, and the f of 5 force is going to be right here. So I'll have this rectangle, it'll be 1 wide, and let's see, f of 5 force is 25 over 16. 25 over 16 minus 1 is, well, 1 is 16 over 16, so this will be 9 over 16. Oops, I've gone down too far. Plus 9 over 16 times 1. Okay? And so, see, so notice that I have these two rectangles below the x-axis. One above these, the products that give me the areas for, the sort of areas for these give me negative numbers for these two because they're below the x-axis, and for this one, a positive number. So I'll have the negative 5 force, right, minus 9 over 16. Negative 3 times 3 is 9, negative 9, and it's 4 over 4. 4 times 4 is 16, plus 9 over 16 times 1, which is 9/16. These subtract off, and I get the total is negative 5 fourths. So that would be the total quote area. It's not really the area because the area is not negative of this. And here's the picture. These two rectangles are below the x-axis, so the Riemann sum treats them as negative. This one is above the x-axis, so the Riemann sum treats those as positive. So here's a second example of a Riemann sum.